Hello guys, in this tutorial we will go over three charts that you may want to consider to visualize your numerical data. Before we start, please, if you find value out of this video, like and subscribe. Also, the link to the code that you will see in this tutorial can be found in the description box. That being said, let's get to it. So for this tutorial, we're going to use the calories.csv file. So if you've been following along with the previous tutorial, so then this is a data file that we used before. Just to give you, a little bit of background on this CSV file. It's just some basic tabular data that comes from an adult study. So here we have information, basic information related to adult demographics. What they were interested here in was looking into the vitals, right, during a workout session. And then at the end of the day, what the goal is just to see how many calories they burn during a workout session. So we have gender, age, height, weight, duration of the workout, heart rate, body temperature, and the number of calories burned. Okay, so first we're gonna start by creating a box plot out of calories. And we went over how to create a box plot in the previous tutorial, so this is just a follow-up. So let's run this first. And now let's run this. Let's zoom out a little bit just to get the whole picture. As I mentioned in the previous tutorial, so a box plot is just a graphical representation of the 5-number summary. Here we see, the minimum, Q1, this is the median, here we see Q3, and here we see the maximum. Okay, so then these lines right here from here to here, and then from here to here, those are called the whiskers. And then these data points, in some sense, they could be considered as outliers, right? And then by far, that's one of the most common applications of box plots, is just to identify potential outliers in your data. Okay. Now, besides using box plots as a way to identify potential outliers in your data, the second most used application of box plots is just to compare distributions. Okay. So, and that's what we're going to do next. We're going to create a side-by-side box plot just to see how it's used to compare distributions. Okay. So side-by-side box plot. Okay. So what we're going to do is we're going to compare the distribution of calories for males and females. Okay. So let's just start with that. So as usual, fix X build these subplots. And this is going to be a two-step process. Okay. When we're using Matplotlib to create side-by-side box plots, so then it's a two-step process in the sense that first you need to subset the data, and then you create a side-by-side box plot. So then in this case, because we only have two labels under gender, so we need to create two data frames in some sense. Okay, so subsetting the data. So I'm gonna call it male calories, and it's gonna be df gender equals to male in quotes, and then we are selecting the calories. Okay, and we do the same for females. Okay, females calories equals to, copy this, and let's update here with female. All right, so up to that point we subset the data. Now we have two series of data points, one for females, one for males. And then now we are ready to create the box plot. So side-by-side box plot. So I'm going to call this box plot equals to X box plot. And then here we enter the data. So then here we enter the data, the two data frames at least here we add the label. So then the first one is male, the second one is female. So let's run this to see what we get. All right, so then here we have that side-by-side box plots. Okay, so let's customize this a little bit. So we can do title, so calories by gender. So X, the Y label is calories. Let's add the grid and let's show it. Okay, and we can also add some color to this if we want. Color, you can see what happened. It complains, so there is an error message. Let's remove that then. Color, let's remove this argument. Okay. All right, so yeah, I was using the incorrect argument, so you just patch artist equals to. Okay. Let's zoom out a little bit just to take a better look at the side-by-side box plots. Yeah. So then again, typically box plots that are used to compare the distributions of two or more groups. Okay, so then here we have the calories for males, here we have the calories for females. And when you're comparing those distributions, you start looking at the width of the boxes. So more or less they have the same width. The median values are more or less the same. However, we can see that on males, right, we have more variability, right, because we have outliers here, and the whisker uh, for males is larger compared to the whisker of females. Okay, so that will be the takeaway message here, right? So then the variability on the calories values for males in this case happens to be larger compared to females. That will be the takeaway message. Okay, but again, I just want to show that, you know, side by side box plots, they are typically used just to compare the distributions of two or more groups. Okay. Now next, when it comes to, you know, when it comes to visualizing numerical data, another common tool that you may want to consider is the scatter plot. And the scatter plot is a two-dimensional graphical tool that will allow you to explore a potential relationship between two numerical variables. Okay, so scatter plot. So in this case, let's create a scatter plot of, for example, let's look into the duration of the workout and the calories. Okay, so intuition tells me that the longer the workout is, the more calories will be burned. Okay, so let's see if that initial hypothesis is in some sense is validated by the data that we have access to. Okay, so let's start by the following: fix x equals to plt subplot as usual, and then creating the scatter plot. Let's use, in this case, we're looking into duration and calories. Okay, let's run this and see what we get. Okay, right, so let's add a little bit of customization. Let's zoom out a little bit. So the title, so we add the title there, X, the label, duration. I don't remember if it's minutes, so then let's delete that, the number of calories. Let's add the grid as a reference and plt show. Okay, so here is the scatter plot. So let's make the title a little bigger. Font size. Thing. Okay, so this is the scatter plot. Again, it's just a graphical representation. It's a two-dimensional graphical representation because we have one variable on the x-axis, we have another variable on the y-axis. And again, the main purpose of scatter plots is just to explore a potential relationship between the two variables. which in this case, we see that, right? We see that the overall pattern as we move from left to right in terms of duration, right? So then calories increase, right? So again, in terms of how we will, in some sense, how you can summarize the relationship, here is that we see a positive relationship between duration and calories, meaning that as duration increases, so calories increases as well. In this case, the relationship is not like fully linear, it's not linear, it's more like a non-linear. It looks more along the lines of a parabola, right? So I would say that it's non-linear. But that's basically how you will use a scatter plot. Now, one thing that I just want to emphasize here is creating the scatter plot is pretty simple. You see that it doesn't take that much to create a scatter plot. Um, what I seen in the past that practitioners or students in general, they try to see things when pretty much there is nothing to be seen. And what I mean by that is once you create your scatter plot, and if you stare at that scatter plot, let's say for 20 seconds, and you don't see anything that gets your attention, or you don't see any specific pattern in the data, probably there is nothing to be found. Okay, and that's gonna be very, very, or that's gonna happen very, very often. Okay, so I know that it takes some time to teach your eyes to see things, but again, once you create your chart, and if you look at it for 20 seconds and you don't see anything that gets your attention, or you don't see um, any specific pattern, so probably there is nothing to be found. Okay, and don't spend too much time explaining, oh, there is a point here or there is a point there. No, just focus on the overall pattern. If there is an obvious overall pattern, talk about that or describe that. Don't focus on just one point being here or one point there, unless you know that if the analysis has to do with identifying anomalies or identifying outliers. In those cases, yes, you need to talk about those points that they are in some sense isolated in the chart. Okay, all right, so then that's the scatter plot. Now in this case, another chart that you may want to consider to visualize your data, your numerical data, again, is, for example, is just to create a heat map out of the correlation. Okay, most of and what I mean by that is the following. So most of the features in this particular data set are numeric. Okay, so let's quickly create first a correlation matrix among all of the numeric features, and then we will create a heat map out of that. Okay, so let me add a title here. So correlation heat map. Okay, so for that, first let's do this in two steps. Okay, so first uh let's create the correlation matrix. So then df drop, and then columns. Let's remove h axis equal to 1. So what we're doing here is we're dropping, excuse me, not h, gender. So we're dropping gender and we're keeping all the numeric columns. Okay, so if I do just CORR, so if I do that, it computes the correlation among those columns. So this number right here, for instance, so then that's the correlation between age and height. This number right here is the correlation between height and weight. This number right here is the correlation between calories and body temperature. What we're going to do is we're going to create a heat map out of these numbers, out of these correlation numbers. Okay, so so here we go. So let's import numpy np, and then computing the correlation matrix. So let's call cor matrix equals to what we have here. Okay. Then after that, we're going to define fig. That's for the size of the plot. Then after that, then we creating a heat map. So what we're going to use is the same that we used in one of the previous tutorials. I am show. Okay. And then let's use the one that I use the most is this one, and this core R. Okay, so that creates a correlation. Now, basically, the heavy lifting to create a heat map is already been done. Now let's just let's add some cosmetics. So then we just need that for the columns. So let's see what happens here. Okay. We're defining that. We're defining the thicks. Okay, and then after that, let's define the label. Access text labels. Now we have some labels here. Okay. Similarly, let's define the labels on the y-axis. Now we have labels here as well. Okay. Now, again, because here we have some sort of overlapping, so then some labels are on top of each other. Let's rotate them. So rotating the axis labels. So then here, let me delete this. So here we are rotating the labels 45 degrees. Okay, now we see the labels that they were rotated. Now we're getting somewhere here. So let me colon here. Let's see what else we can add. We can add a color bar. And a color bar. It will be C bar equals to PLT color bar. Okay, and then we can add label there. Let's let's add that. Close it there. Okay, so that's that. Okay, so it's a little bit weird to read it in this way. So let's use, let's say 270. Okay, or let's just maybe 90 rotation. Okay, that's a little better. Okay. Now notice that the correlation is set as -1, but in this case, when we look at this data, typically, or the smallest one is -0.004. So let's update this a little bit. So then here, when under I am show, we can specify, here we're specifying that the minimum is -1. Let's just set it up to be 0. Okay, and then now we have the correlation looking a little better. Now, the last thing that we're going to do is we're going to add the actual correlation numbers in each of the cells. Okay, so for that, basically what we need to do is just a for loop. So adding the correlation coefficient. So we did something similar on one of the previous tutorials. So we start with for I in range. Yeah, so then there is no match to be set here. It's just adding the correlation numbers from this matrix. So then, yeah, it's just looping through this correlation data frame, and then it's just adding those labels. Let's run this. Now we have those correlation numbers. Okay. One last thing, just to get rid of these. Let's see. Okay. So, what? Let's add a title and PLT show. Okay. All right, so that's the correlation map. Again, this is just a visualization from the correlation matrix that we have here. A couple of things that, by adding colors that you can easily identify here is just, the closer the correlation is to either 1 or -1, so then that means a strong linear relationship. And we see a couple of strong correlation numbers. So we see that, again, keeping in mind that calories is the target variable, we see that duration, heart rates, and body temperature are highly correlated with calories. Okay. Yeah, and those by far are the three features that they are the most correlated with calories. And then we see other features, right, that they don't have any correlation with calories. So then, for example, this one right here, height is pretty much not correlated with calories. Okay, and weight, same thing, right? Very, very small correlation. Okay. What you need to keep in mind is that correlation is measuring linear relationship. So having a correlation, very a small correlation like this one, 0.02, or like a zero correlation, that doesn't mean that the variables are not related at all. That only means that they are not linearly related. So they are related in a non-linear fashion. Okay, so that's something that sometimes practitioners get confused because they see a small correlation, they make the assumption that there is no relationship between the two variables. No correlation, it only means that there is no linear relationship between the two variables. They could be non-linearly related. Okay. But again, going to the purpose of this tutorial is just another graphical tool, which is the correlation heat map that you may consider just to visualize how linearly related your numerical features are. Okay, so it's very simple, right? It's just, again, the correlation heat map is just a graphical tool of the correlation matrix. Okay. Here we have a scatter plot, which is a graphical tool that allows you to uh, explore potential relationships between two numerical variables. One of the numerical variables go on the x-axis, the other one goes to the y-axis. And then here we have the side-by-side box plot, because that's another graphical tool that allows you to compare the distribution of two or more groups in just side by side. Okay. So yeah, so then those are three charts again that you may want to consider to visualize your data: side-by-side box plot, scatter plots, and a correlation heat map. Okay. So once again, if you find value out of this video, please like and subscribe. Yeah, that's all I have for this one. See you on the next one.